Hello everyone, I'm Tommy.
I'm Saki.
And I'm Franklin.
And this is the Battery Lab.
This lab is broken into 3 parts. For the first part, you will be measuring battery's efficiency by charging and discharging a lithium polymer battery. This efficiency is a measure of the fraction of energy sent to the battery that may be transferred out of the battery. The equipment that you will need is a lithium polymer battery, a power supply, electric load, resistor, and the QuickDAQ 2013 software. Looking at these diagrams for our setup, we can calculate the voltage and the current. The amount of charge transferred, delta Q, and the amount of energy transferred, delta E, either to or from the battery, in the time are found with this formula. We can use this to calculate the efficiency. Let's get ready to take our measurements. First, let's set up. Turn on the computer and log on as student. Set the power supply to 0 volts and 0 current, then turn it on. Adjust the voltage to 4.1 volts. Connect the battery for charging, and then connect the power supply to the battery. Adjust the current to 1 amp, turn off the power supply. Next, go back to the computer. Double-click the QuickDAQ 2013 icon. Go to File, Load Configuration, and load the configuration file BatteryLab 1016-2013. In the Acquisition Configure window on the left, click on the Recording tab and verify that the Enable Continuous Acquisition box is checked. Click the Acquisition tab and verify that the sampling frequency is set for 1 Hz. Click the Record button in the toolbar to start acquiring data. After 2 to 3 data points are displayed, turn on the power supply. After approximately 10 minutes, click the Stop button in the toolbar to end the data acquisition. Turn off the power supply. Turn on the electric load. Set the discharge current to 1 amp. Connect the battery to the electronic load and start recording. After 2 to 3 data points, press the on-off button on the electronic load to begin discharging the battery. When finished, press the on-off button to stop the discharge. Save your data on the desktop. Use a name you can remember. Repeat the earlier steps to recharge the battery and measure and save the charging data. Repeat the discharge steps, but set the electronic load discharge rate to 2 amps and reduce the duration and number of measurements to about 5 minutes. While you're waiting for the battery to charge for part 1, you will be shown the Hyperion battery charger has been used to discharge 1 pack and charge another one. This is a group of batteries attached together. The instructor will give you the charge and discharge graphs. In your report, you should present both graphs and determine which cells in the pack, if any, should be replaced. For this part, you'll be using 2 battery testers and a voltmeter. All of the batteries are 12 volts. The voltmeter will tell you the output, so you may be able to tell if the battery is bad with low voltage. However, it is still possible to read 12 volts. With the solar battery tester, you can check a battery with multiple settings. For this lab, we will test the cold crank amperage. Hook up the alligator clips to the 2 terminals of the battery. Hit the menu button to select the CCA. The meter will display a number for the CCA. Check the battery to compare what it is rated for. For the battery minder tester, hook up to the battery terminals and check the indicator lights on the tester.